This is a continuation of the series of videos on Year 10 Science, the topic of motion. This is part 3, looking at graphs of motion. Suppose I'll give you this scenario. Time is on the x-axis, it's in seconds. Goes from 0 to 4, 6, 8. Looks like this. No, the scale isn't that good, that's all right. 6, 8, 10. And on the y-axis, suppose you're going up by 1s, 2, 3, 4, 5. And the y-axis is velocity v, meters per second. Okay, v with an arrow on top, the arrow means it's a vector. Velocity is a vector. It's something that has size and direction. So 10 meters per second west, for example. Okay, let's suppose I want to go from here to an acceleration time graph. To do this, important to note that the time stays the same. So 0, 2, 4, 6, 8, 10. Time on the x-axis stays the same, doesn't change. Time is really the independent variable in this case. Time is changing over time. Time is changing. It's not going to be anything that's other than what you have here. So it's really the same time, but you're measuring different stuff. In this case, acceleration, that's the y-axis, a with the arrow on top, meters per second squared. So we need to first identify that acceleration a, keeping out the arrows for now, because we're looking at magnitude, the sizes in this case of these quantities. It's the change in velocity v over the change in time t. Now that's simply the rise of a run. Whenever you see a fraction like this, rise of a run, that's the gradient, that's the slope of a line. So if you look here, there's 3 slopes. Let's break this up into 3 sections. Remember, break it up always. Your velocity time graph or displacement time graph, even distance time graph. There's one section here, one shape, another one here, 2, and another one here, 3. So area 1, I should say the first shape, a sub 1, let's call it. Acceleration's rise of run. The rise here, let's suppose, is 4. And the run, which is here, is 4. So it's just 1 meters per second squared. Let's use the scale here, go up by 1s, 2, 1, -1 I should say, and -2. Now acceleration and velocity, they can be negative. The negative just means direction. If you have 1 meter per second squared, that means you're moving, let's say, to the right, the positive direction. If you're moving to the left at -1 meter per second squared, if you have -1 meter per second squared, that's the same thing as saying you're moving 1 meter per second squared to the left. Okay, you have to choose a reference point. Okay, that's the origin here. Okay, that's positive acceleration, and that's negative acceleration here. That's deceleration, in other words. So for the first shape, 1 meter per second squared from 0 to 4 seconds is this. Stops there at 4. The second shape there, the acceleration a sub 2 is this rise, which is 4 once again, over the run, which is from 4 to 8 seconds, and that's 4 divided by 4, and that's 1 meter per second squared. So once again, so the acceleration is this constant. It's, my apologies, what am I doing? It's actually 0. It's 0 meters per second squared, because a flat line on a velocity time graph means there's constant velocity. You're moving at constant speed in a particular direction. So there's no slope. The slope is 0. So from 4 to 8 seconds, you drop this line down here to the 0 axis from 4 to 8 seconds. Okay, because it's 0 acceleration. Then the last area, the last shape, a sub 3, is the rise, which is once again 4, divided by the run from 8 to 10. The difference is 2. So you get 2 meters per second squared. So 4 over 2, you get 2 meters per second squared. Excuse the mess. Let me zoom in a bit. It's harder than it looks writing on this thing. So from 0, you go up to 2. Use a different color. Use black. Up to 2, and it stays flat, okay? Constant acceleration. And that is your... Oh, and it goes back to 0. Drops back down to 0 because, as you can see here, the velocity goes back to 0. If there's 0 velocity, there's 0 acceleration. And that's it. That's your acceleration time graph. So to summarize, once again, you always break up your graphs into sections. You use the formula that you know from the formula sheet. And the rest is just using things like gradients, rise of a run, the slope of lines, and knowing that constant velocity means acceleration is 0.